Hello, my name is Mary Getty and welcome to my Rotovap video. So similar to simple distillation, which works best with substances whose boiling points are greater than 100 degrees Celsius apart, or fractional distillation, which works best when substances have boiling points that are less than 100 degrees apart. The Rotovap is ideal for removing solvents, particularly volatile solvents, from non-volatile samples via evaporation. Unlike the other two methods of distillation, the Rotovap is much faster and much more efficient, requiring less energy and producing much more pure results. Similar to the other two forms of distillation, you begin with your initial substance in a round bottom flask. There's an apparatus for condensing the solvent, as well as a source of heat that helps boil and initially run the evaporation. However, the Rotovap also has a couple key differences. The Rotovap primarily increases the rate of evaporation by reducing the pressure to lower the solvent boiling point via a vacuum pump, or in this case, a water aspirator, that reduces the pressure above the bulk solvent. In addition, the sample is mechanically rotated via the Rotovap that increases the effective surface area and helps the solution boil much more evenly, as well as keep things moving, and agitating it also helps with the boiling process. In addition, the substance is also heated via a water bath as well. So to conduct this technique, an ice water reservoir may be used to help aid in condensation. However, the first necessary step would be filling the round bottom flask no more than halfway with the solution to be distilled. Filled with more than this, it may boil over, causing a loss of substance or even potentially damage to the system. Next, that flask will be connected to the Rotovap's bump track, which helps maximize yield and purity by making sure that anything that gets knocked out of that flask is contained and then can be evaporated away again. Be sure to secure those with a clip, though, to make sure that nothing comes loose or potentially even breaks. Next, lower the flask into the hot water bath to heat, but ensure that the clip is not submerged. Because of the heat of the water, it could potentially melt and thus damage the apparatus. Next, decrease the pressure via the vacuum source, in this case a water aspirator. Being sure to close the stopcock and make sure that there is that vacuum seal. Next, begin rotating the flask, which, as we discussed earlier, helps with the evaporation process. As this mixture continues to evaporate, continue until one of two things happens. If the desired compound is solid, evaporate until a film or a particulate begins to form, as depicted in image B primarily. However, if the desired compound is liquid, evaporate until the expected volume of either the product or the expected volume of solvent is obtained, separate from the initial mixture. You could also be looking for a color change, or most likely a change in boiling points. Regardless, allow the system to rest before clicking any buttons to ensure that the last vestiges of solvent are indeed boiled away. To stop the evaporation process, reverse the initial steps by opening the stopcock, stopping the rotation, turning off the vacuum source, lifting the flask from the water bath, and removing the flask. And there you have it. That is how you perform a rotary evaporation. Have a nice day.